Welcome back for the last time in this course. The authors of this book has decided to end with a bang. And so we're going to be talking about the Big Bang Theory and the formation of the universe as a huge explosion of matter and energy that has continued to expand over time and through space. And so we'll look at this amazing idea and weigh the merits of it as we can, and see what it is that we don't know in science. So I hope you enjoyed this course. I've enjoyed teaching it, and I look forward to other courses with you. The cosmos is an ancient Greek term basically meaning everything. So everything that is, everything that we know about and everything that we don't know about is considered to be the concept of the cosmos. So I suppose the universe is a smaller, more localized term, but they could be synonyms for each other. But cosmology is that study of the universe. And in studying the universe, it's not just studying what's in the universe, which is a huge part of cosmology, but also this idea of where did it come from, its evolution, its origin. There's some iffiness about that. How do you go back? How do you simply can take what we can see, the evidence that we can see, and make proposals. But often there will always there's always problems with that because it can't be replicated. You cannot do an experiment to replicate something over and again. All you can do is make measurements of things that we can see, and then imply or infer from what we see some proposal that would make sense. So cosmology is more than just the origins of the universe, but it's essentially what you study in Earth science about cosmology, other than the fact that there are other galaxies, etc. That's part of cosmology. Now, the big theory here at the mid part of the 20th century was that if we see an expanding universe, what does that mean? If it's expanding now and it's continuing to expand into the future, then if you go backwards in time, then it must have been smaller and smaller and smaller. Well, eventually that smallness gets to a point smaller than the period at the end of a sentence, where all of the matter in the entire universe, everything that exists, is somewhat in the densest possible space. And then there is a kind of a trigger point where it explodes, and as it explodes, it continues to go outwards. Okay, so this huge amount of limitless space being filled by matter that once occupied almost nothing is pretty much the idea of the Big Bang Theory. The Big Bang Theory suggested some radiation that would be recordable or measurable, and in the 60s they were able to find some of this that we'll look at in just a second. They found some first evidences of the radiation noise that would be consistent with this theory. So it was the first support that this theory had. So we've already mentioned previously that the universe the solar system is part of a Milky Way galaxy, and the Milky Way galaxy is part of the local group, and the local group and the clusters and the large clusters and the superclusters seem to be going away from each other. And as such, the universe tends to, at least shows itself to be expanding. And that expansion can be calculated by this Hubble constant that we looked at in the last lecture. Okay, so mathematically it's recordable that the distances away from each other is expanding at a certain fixed amount. Well, if the universe is expanding, it suggested that there was a point where it was all concentrated together, and that's the idea of the Big Bang Theory. I don't know if it's the most elegant of terms, the bang. I guess this is the idea of that you have an outward expansion of energy and material that is now filling an empty void where there was nothing in the universe before, and then it's being filled by this expansion as it's going. Now, if there was a point where it was all concentrated at a place and now it's expanding, what does that imply for the future? How do you look into the future? Because it's really looking into the deep, deep past is very much the same as looking into the future, with pretty much as much iffiness as looking into the future. How do you predict what's going to happen? Well, that's essentially what you're measuring into the deep past when there was nothing there to record. All we have is the data that we can observe at the moment. So if we can look at an expansion, remember the red shift that we saw as one galaxy tends to be moving away from another, then if it is expanding and it came from a point, well, it must be going into, like the angle is getting bigger and bigger and bigger as it's going away from the vertex of the angle. So is it going to expand forever? Well, that's one of the considered possibilities. It could simply just continue to expand, always expanding, always expanding. Could it be to a place where it runs out of energy? So the energy, because you have it's moving weights, and that requires force, and that force requires energy. Is it possible that that energy is going to lag in some ways, and it's going to kind of come to a stabilizing point where it will expand up to a point and then stop expanding? Some people propose that. Other have the idea that it's going to expand up to kind of an upper limit, almost like throwing a ball in the air, and it comes up to an upper limit and then comes back. So will it expand to some upper limit and then start contracting due to gravity again? If the energy tuckers out, there's still gravity, and that gravity could initially pull it back together into this pinpoint again. So there are various people arguing for these ideas. Is it esoteric? Is it out there? Is it pertinent? Some people would say absolutely. Other people would say I'm not really sure about that. So these possibilities based upon the idea of the Big Bang makes for good discussion. It was Bell Labs in the 1960s that first picked up kind of static on their equipment as they were putting in telephone systems in the U.S. And it was determined that the static seemed to come from everywhere. It wasn't picked up from one location. It was picked up from all locations, coming in from space in every direction. And that it corresponded to a very, very cold object emitting energy. So it was very, very low, kind of background noise, and that's why it was called background radiation. Kind of just the fuzz in the back of the radio station. Well, it happened that this matched very closely the theory of the Big Bang, that there would be this residual radiation left over after this initial explosion. So what it was the residual echo, if you will, of the initial explosion of the Big Bang. And then if you can measure this background radiation, which people have intensely measured it, you can see that sometimes there will be slight wiggles in this radiation. So the radiation's amplitude will rise and drop. The implication that some people see is that these are markers of major events in the history of the universe. So would it have been a certain wiggle would have implied that was the coalescing of a galaxy, or that was the coalescing of a solar system of some type. Okay, so can you kind of go back and map what happened chronologically over deep time, as opposed to with this residual leftover echo? So it would be like listening to the echo of a gunshot in the woods and tracing it back to its location and what kind of temperature variations were in the air as the bullet hit the different pockets of air as it was flying from the gun. I mean, it's very, very detailed type of work, and with lots and lots and lots of iffies. Okay, so that's kind of this idea. But it's the background radiation that we're actually able to measure. Everything else is inference from that. Okay, so this radiation was first detected by Bell Labs and then later studied in a lot of different ways. So there's probes. You're trying to get it kind of away from Earth because the atmosphere of the Earth kind of guards us from this radiation, kind of keeps it away from us. So you kind of need something very far away from either very high weather balloons or orbiting probes, etc., that is now studying this radiation in detail. Because if it's giving us information that is very pertinent, it's worth the study. So we were able to then use the Hubble model, use the information gathered from these probes to kind of measure what is how fast, how big is it expanding, and likewise. This brings us back to the idea of dark matter. So what is causing the pull? What is causing the expansion? What is it that's doing this? And this gave more and more evidence as people were scratching their heads of maybe there is matter that we can't see with our telescopes, we can't detect through the energy. So maybe there is an energy that we can't detect called dark energy, or there's a matter that we can't detect called dark matter. Some people would scoff at this, laugh at this, that you're simply making something up. But again, it's from what we can measure that makes us make proposals. What is it that could answer what we see? Is there, and wild ideas, could it possibly be more universes existing all at once? Cosmologists are struggling with that, with this idea of string theory and multiple universes, like different universes, like different pieces of bread in a cosmic loaf of all different universes happening at the same time. Sometimes this would explode your brains. This book ends with this idea that we don't know very much about what our world is, what our universe is, and that we're continuously gaining information. As we explore, as we scratch into what we see and measure and think, what does it mean by me seeing these numbers on this graph? Is it possible that this could be what's going on? Is it possible that this could be what's going on? That's what a science does. Science comes from the word know, to know something, but science is continuously on the edge of not knowing what they're looking at, not knowing how much they don't know. And so there's continuous exploration, continuous forward moving into the unknown. And that's part of the fun that would give someone the impetus to do the hard work that science requires. So I hope you've enjoyed this course. I've enjoyed teaching it to you, and we'll come back for some different types of sciences in the future.